Talk about the concept of friction. First, we have different cases here. So let me take this video as case 1. That is the case when an object lies on a flat surface. So let's say this is my flat surface. Then I place an object of, so if I place an object on it, so let's say this object, we have a mass of m. So this block, let's say, is a block, a mass of m. So now if I place this block on this surface, so it should be something like this. So I place it on the surface. So now many things can happen to this block on this surface. Now is either this block is at rest or this block will move. Now if this block is at rest, that means the upward force is equals to the downward force and the right force is equals to the left force. But for every object, friction usually opposes the motion of any object. Without friction, objects will continue to move till eternity. So now, if I apply a force towards this direction, there must be another force that will oppose this motion in this direction. And if you apply a force in this direction, there must be another force that will oppose it towards this direction. So now what is that force that opposes the motion? Then it is called frictional force. So if this place is my applied force, then here will be my frictional force. That is the force that opposes my applied force. Meaning if I try to drag this block towards this direction, let's say I want to drag this block towards this direction, so then there will be a force that will be pulling it backwards towards the opposite direction. So like that. So the weight of every object usually acts downward. That is W. Then there should be another force that will oppose it acting upward. It's called normal reaction. So now according to this diagram here, Fr is mu r, that is coefficient of friction, times r. What is coefficient of friction? That is the degree of smoothness or roughness of a surface. So now the how smooth or rough a surface is, that is the coefficient of friction. Now take note, Fr is always mu r. That is Fr is coefficient of friction times r. So where r is this normal reaction. So take note, this weight is what? Mg. Weight is mass times gravity. So if this object is not moving, that is if this block is not moving, many things can happen here. So if the block is not moving, that means your applied force must have been less than or equal to your frictional force. That is, for this block to stay at rest, is either your applied force is less than or equal to frictional force. Because if, for example, the frictional force here is 20, the force opposing your motion, and you are applying a force of 10, obviously this block cannot move, because the force you are using to apply, the force you are applying here cannot move this 20. So the force that can move this must start from 21 Newton. At least it will move a little, so upward, because if the force is also equal, it cannot move. So that means for this block to move, Fa must be greater than Fr. So if Fa is now less than or equals to Fr, the block cannot move. Now if this block does not move, then we assume Fa is equal to Fr if the block does not move. So applied force is equal to frictional force. So let's assume that. Now what is your Fr? We already know that Fr is mu r. That means Fa is also mu r. That is coefficient of friction times r. And that means Fa is equal to Fr is equals to mu r. That is, if this block does not move, this is the formula. If the block does not move, take note. Now, tends to move or about to move does not mean it has moved. If it moves, then there must be acceleration. If there is no acceleration in your question, then the object have not moved. Now, Fa is equals to Fr, then is equals to mu r. Then this is your applied force and frictional force. So the two together, since they are equal, we usually say F is mu r. But take note, it is Fr frictional force that is mu r, coefficient of friction times r. This your Fa is just an applied force. They are only equal if this object does not move. That is when you have F equals mu r. What is now r? Weight is acting downward. So if this object does not move, then r will also be equals to the weight. Again, if the object does not move, applied force will be equals frictional force here. And again, your weight will be equals to the normal reaction. So that means your normal reaction, since weight is mg, normal reaction is also mg. So from here, this formula can becomes F is equals to mu mg, that is mu r. R is now mg, so F can be mu mg. So when can we use this formula? We can only use this formula if the object does not move. Please take note. If this block does not move, that is, if it does not have acceleration, this is your formula. Now let's see, what if this block move and if there is acceleration? So let's say there is acceleration. This is just the concepts first. So now let's say there is acceleration. If there is acceleration, what will happen? It means the applied force is now greater than the frictional force. So if there is acceleration, that means my applied force is greater than frictional force. But if there is no acceleration, it means Fa minus Fr, that is, my applied force must have been greater than the frictional force because the object moved. And if the object does not move, it means Fa minus Fr is equal to 0. Meaning if the object does not move, then there is no acceleration. The object will be Fa minus Fr is 0, and that is how Fa is equals to Fr. But now I want to discuss if the object now move, that is, if the object have acceleration. Then if it accelerates, that means your applied force must have been greater than frictional force. That means Fa minus Fr must be equals to mass times acceleration. So if the object moves, then Fa minus Fr is mass times acceleration. But if the object does not move, then Fa minus Fr is equal to 0. So please take note now. Anytime the question, like in friction, in this case 1, object lying on a flat surface like this, if the block or any object there move, then there must be acceleration. Then Fa minus Fr is equals to ma. But if there is no acceleration, then is equals to 0. Take note. Now what is your Fa? We already know that Fa is applied force and Fr is mu r. Take note. Always Fr is mu r. That is coefficient of friction times normal reaction, while Fr is the frictional force. So Fa minus mu r is equals to mass times acceleration. Then Fa is equals to ma plus mu r. So this is the formula you will be using if in this case the object move. Take note, this is just case 1. So if the object have acceleration, then this is your formula. So that is it. Now there are additional info that we can have here. That is, if there is additional force here, the question will state it. That is, if this block is now moved with an additional force, or anything. So we have to do something like that later. We can talk more on this on scalar and vector, then relate it to friction. But for now, let's discuss this case. So now, there are two things I've discussed now. So for this case, if the object moves, let me say does not move first. If the object does not move, that is if there is no acceleration, then Fa will be equals to Fr will be equals to F, then which is mu r, and r is equals to mg. So if the object does not move, now if object accelerates, you should know if object accelerates, that means there is change in speed. Then if objects move, then Fa minus Fr is equals to mass times acceleration. Take note. So if the object moves, that is the formula. So now let's see example to back this concept. Remember, this is case 1. We still have different cases, but I'm starting with this. Object line, the question will tell you, and any question you have to sketch. So let's see example now on this case. So look at this question now. A wooden block of mass 1.6 kilogram, that is, we have a block of mass 1.6 kilogram, rest on a rough horizontal surface. Full stop. If the limiting frictional force between the block and the surface, so limiting frictional force, so is 8 Newton. Calculate the coefficient of friction. Now if you look at this question, nothing like the question accelerate or find acceleration or what is the acceleration. That means this block does not move. It's just resting on the surface. So I have a flat surface and I have a block of mass 1.6 kilogram. So if my applied force is this way, then this place must be my frictional force, and frictional force is given here as 8 Newton. Remember, weight usually acts downward, so W is equals to 1.6. that is, weight is mg, abi, definitely W is 1.6 times g is gravity, so I will assume it to be 10, and it's given in the question that I should take it to be 10. So weight is now equals to 16 Newton. So if weight is 16 Newton, then the normal reaction, remember, if the object does not move, then R is equals to W. And since W is mg and that is 16, R is also equals to mg, and R is equals to 16 Newton. So that means your R is equals to the weight acting downward, because the object does not move. And if the object does not move again, it means my applied force is equal to the frictional force. But my frictional force is 8. That means applied force is also 8. And the two together, Fa equals Fr, we can just say is equals to F, as in that is it. But they are not the same. It's only equal if the object does not move. Now, since the object does not move, what is the formula? There are two formulas you can use. One, F is equals to mu r, and also R is equals to mg, and we've used the two already. Now, question say calculate the coefficient of friction. So that means from F equals mu r, what is the coefficient of friction? So how smooth or rough the object is. Then that will be F over R, like this. So now we know our F already. F is the applied force, which is also equals frictional force, because the object does not move, as in here. So that is it. So Fr is equals to 8, which is equals to Fa or F. So that means 8 over r, where r is 16. Then 8 over 16, that is 0.5. Coefficient of friction does not have units because this is 8 Newton, this is Newton. Newton will cancel out. So that means that is how smooth or rough the object is, 0.5. So that is the answer to this question. Now in another video I'll do pure examples. So this is just first video. So what's the next video? So I'll do examples on this first case.